Okay, so for hydrocarbon leakage, for methane leakage, there are a couple of things that are perhaps important. One is that the area in which we live, in Pennsylvania, New York State, and whatnot, we're leaking hydrocarbons as we speak all over the place. Not because of human activities, but just from natural leakage. The area is endowed with rich organic beds in the subsurface. As those hydrocarbons migrated, matured, the gas was expelled. Gas actually hydrofracted its way out of the Marcellus shale 300 odd million years, 250, 300 million years ago. In the first hydrofracking, if we hydrofrack it again, it'll be like a refried bean. We'll be refracking it for the second time. But the gas has been trapped in there very stably by capillary seals, which we can get into later, for this intervening 200 odd million years. So it's trapped very stably there under sometimes considerable overpressure, but it's not leaking out at all. But what had happened is that the area was flooded with hydrocarbons in this maturation event that matured the shale, the gas in the shale, in the Marcellus. And there are little pockets of hydrocarbons, both biogenic and thermogenic, all over the stratigraphy of New York State. And as groundwater circulates through this subsurface, it dissolves some of that methane and brings it to the surface, and as it decompresses and as it flows, the upwelling flows under streams and areas of low topography where groundwater discharges, the methane can exsolve and discharge, and there are lots of examples of these natural seeps. It's a known hazard, and when you drill a water well, that you may encounter a methane pocket and get a puff of methane and even burn up your rig. There are faucets in Pennsylvania that you can light on fire, and you could light them on fire 50 years ago. People my age tell me that they enjoyed doing this when they were kids. There is a waterfall in upstate New York where there's an eternal methane flame burning. You can go on the internet and find pictures of it. It's a methane flame behind a waterfall in a state park in New York State. So this leakage is quite natural. It's happening all the time, and it's built in and accommodated into the methane equilibrium that we're in right now, roughly methane equilibrium. If we go into areas like Pennsylvania, like the Dimock area of Pennsylvania that's already leaking methane, we may or may not encourage extra leakage. You could argue it both ways, I suppose. You could say that, well, you might not encourage the leakage, and by tapping out pockets that were already there, in shallow pockets, not down in the Marcellus where it's trapped, but shallow pockets, you might reduce the tendency for future leakage. But the leakage is happening. It's happening naturally, and when you abandon wells and whatnot, those wells might encourage more leakage or might not. They might have reduced it. But that leakage is part of our current equilibrium, and what we're talking about is the extra leakage that's on top of that related to whatever drilling you might have. Okay, where this comes to bear is in some of these studies that have been done most recently by Colton and others, flying planes around in the coal producing area, and also now natural gas drilling area of southwestern Pennsylvania. The area there, what they found when they flew their plane around was that they found some methane seeps. These methane seeps were chemically not the thermogenic methane that was coming from formations like the Marcellus or from the gas production, but from very sparse data it looked like it was coal bed methane. So in that area where you have extensive underground mining of coal and where you have in fact ventilation shafts which are still operative in order to keep the methane from accumulating and being an explosion hazard, you of course have methane emissions. Those are steady state or steady over recent times emissions. If you drill a well into that environment, you might get some extra production of methane in the shallow subsurface as you facilitate that leakage. And that could help close the gap between the top-down and bottoms-up estimates. But the natural leakage that's there is already part of this equilibrium between methane and methane leakages and methane concentration in the atmosphere that we've established. And so we're learning some interesting things in doing this, but it doesn't necessarily change the leakage that would be damaging from new production. In other words, to be not a good idea, natural gas would have to leak as a consequence of its production, something like 6 to 9% of consumption. And the leakage that's going on already, or that's part of the natural part, can't be added to that production-related leakage in that sort of a calculation.